All right, cool. All right, well, thanks everybody for joining us. This is the kickoff of the Practical ML.NET user group. And today we're going to hopefully dive some deeply into training ML.NET on GPUs with Google Colab. And so before we get going, I wanted to give a thank you out to Apress. Apress has given us some digital copies of ML.NET Revealed to give away at each one of these events. So at the end, we'll just draw a random winner. And I will reach out to you and give me your email address. We can get your info over to Apress and get you a copy of this book. I don't want to talk too much about me, but basically I've been coding and in technology for over 15 years now. Good majority of that time has been in .NET and more recently now in .NET Core. Really enjoy that that framework. I can't get enough of .NET. Love it so much. But you know, also do a little bit of Python, a little bit in Golang. But I'm really excited about machine learning in .NET and where they're headed with this. So hope they keep the momentum up, and you know, we can be talking about this for years to come. So what we're going to talk about today is we just want to real quickly look at Google Colab and what it is. Then we're going to talk about setting up Colab to run ML.NET. We're going to talk about how we get our training code up to Colab. Then we'll actually look at some of the code. We'll run some training. We'll run through the entire notebook in Colab so you can see from start to finish how you set it up, how you stage your data, how you train, and then actually get your model back out. At the end of that, we'll have a few closing thoughts on pros and cons of using Colab, and then we can go into a Q&A. So what's Colab and why would we use it? So Colab, this is straight from Google's website, and it's basically the way they describe it as an environment where you can arbitrarily execute Python code through a browser, well suited for machine learning, data analysis, education, and technically it's a hosted Jupyter notebook, right? And it gives you free access to computing resources, including GPUs. Now, what's really cool about Colab is you're not limited to Python, right? So the minute you fire this thing up, you are going to have a full Python environment with a Jupyter notebook. There's going to be Anaconda installed. So you're going to have access to, you know, all the things you would expect to have in a Python environment. So pandas will be there, NumPy will be there, blah, 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 blah. But what's really cool about Colab, and it's a little different from some of the other ones, is this is pretty much just a straight Ubuntu environment, right? So there are some restrictions on what you can install in there. So for instance, like I couldn't go and install Docker and run Docker containers in there, but they do give you a lot of flexibility, right? So you can run apt-gets in there and download and install other frameworks and libraries. But one thing to note is from their docs, Colab focuses on supporting Python and its ecosystem, right? So if you hit any snags in here, don't expect to be able to go into Google's support and ask for help on running .NET. Probably not going to help you there. But this is definitely a valid scenario for you. So let's look at some of the various flavors of Colab. You can go free. You can go 100% free here and get access to GPUs. It's a great way to get up and going, and I did try this for a number of weeks, and I can testify that it does in fact work. Currently, I have moved over to the Colab Pro plan, which is $10 a month basically. And the reason for that is I really wanted the faster GPUs. I wanted the more memory. You do get more storage space as well, and you do get longer runtimes there. So it's been really great for me at the $10 a month, but if you want to go even further, you can go up to Colab Pro Plus and spend $50 a month. And honestly, the bigger things you get there, the biggest thing is the background execution. And we'll talk about that a little bit later on, but basically Colab has a timeout since you're interacting with it via the browser. It will time out after about an hour and a half of inactivity. So you need to make sure that you're kind of watching it, or you have some sort of, and again, we'll talk about it later, some tricks to keep that idle not happening. But with Colab Plus, you do get background executions, which is really great. And you get even more storage, which may be critical to folks with a ton of training data. Now, Colab's kind of tight-lipped on what you get at what levels. It's really hard to find solid numbers. You will not find these numbers in their docs anywhere. At least I couldn't find them. But this is some data that was collected by a blogger, and my apologies, I meant to have the link and the credit here on this slide. I'll add that later. But you can kind of see what you get here, right? So at the free level, you get about 16 gigs of RAM. You can run for 12 hours. And you know, that's not bad. At the Colab Pro, you get access to a wider variety of GPUs. Your RAM goes up to 32 gigs. Run times can stay on for about 24 hours. The storage isn't in here, but at Colab Free, you get about, I want to say it was about 60 or 70 gigs of space. At Colab Pro, you get about 120 to 125 gigs of space. And at Colab Pro, I think it goes up to 230 gigs. But these are things just to keep in mind as you're bringing in your training sets, especially when you're doing image classifications, because that space can go pretty fast. So again, Colab Pro, you're basically getting access to the same GPUs, but you see the RAM goes way up, and the background executions are really the big thing there. So why would I use Colab over X, right? So I kind of want to just throw a few things out here. You know, Azure, obviously, since we're in the .NET space, Azure is sort of the no-brainer for where you'd want to sort of do some of this work. And I'm a huge fan of Azure. I think they have a ton of great offerings in there for machine learning. But for me in particular, over the last few weeks, I'm working with a startup, and they're not in Azure. They're over on GCP, right? So for me to go and spin up resources in Azure just to do my machine learning, it's a little bit of a neck break activity. It's not that easy to just go in there and just spin up Azure for machine learning. You can, but it's a little bit more work involved. Kaggle's out there, but Kaggle is 100% a Python machine learning platform. You cannot install .NET there. I've tried. I was trying to do my due diligence here and see if I could actually install it. And similar with a platform, I think Gradient Notebooks is one that sort of gets compared to Kaggle. They block apt-get in there, so you cannot do an install of like .NET there. Then we have things like AWS or the Google Cloud platform. Similarly, yes, I could spin up a VM there. I could run some training there. I could use some of their built-in products, but it's just one of those things where you know, you want to keep your eye on your costs, and running models for hours at a time on these platforms is going to be expensive. If you don't mind, can you mute? Everybody can mute. So anyways, the long and short is there are a lot of options out there, but you know, for this one, I want to specifically look at Colab and how it's sort of different from everybody else. So who should be using Colab? Obviously, individuals and students. If you're just looking to play around with ML.NET on GPUs, this is a great way to start, right? Because you can get in there and use the free tier, and if you find that's not enough, you can very cheaply go up to the Pro at $10 a month. So it's just a great place to sort of play around with GPUs. Startups, as I mentioned earlier, I am working with a startup currently, and this has been working out really well for us, mainly because we're at that Pro level for $10 a month. It's crazy inexpensive, right? So it's a great place for us to get in there, test these models out, test the training, see what kind of accuracy we're getting for very low money. If you don't have access to GPUs at all, like myself, I'm a MacBook user. I couldn't get a GPU if I wanted one. So this is a great option for me because I do want to train on GPUs. I just can't do that locally. Larger businesses, this probably isn't a great solution for you. You know, speaking to the ecosystems for, if I had the money and the time, I would move all this into Azure and I would do it there. But again, that's not an option for everybody. So, you know, this is definitely, as you get bigger and you're a bigger company, you're moving things into, okay, I was going to make sure I didn't lose the call. As you're getting into bigger workloads and stuff, Colab's probably not going to be the space for you. All right, so we're going to talk now about how do we set up Colab to run ML.NET. So it's fairly straightforward. However, there were a lot of hoops to jump through and a lot of trial and error that I went through to make this work. So basically what's going to happen is you're going to see the notebook that sort of gets Colab up and running. You're going to go, oh, that wasn't too bad. But there was a lot of hours that went into that to get it to work correctly. So these are some of the following resources that we looked at, and we're going to look at these very briefly, but just so you know, at the end of the slide, there are reference links for all of these. So we relied heavily on the image classification trainer class docs. These have a ton of great info on what's required for running on GPUs. The SciSharp TensorFlow.net docs are great. There are definitely some gaps that this documentation fills in. And then the TensorFlow for C pages give you sort of the downloads and then how to install those. And we'll take a look at those in a minute. And just hundreds, this probably should be thousands of Google searches because I spent a lot of time on this. So from the image classification trainer class docs, this is the image classification docs from Microsoft. The big thing to call out here is the prerequisites. They call out CUDA version 10.1, and I don't know how to say it, CUDNN version 764. I will say these are not in Colab. Colab is on CUDA 11.2. However, these, in my opinion, should probably be listed as recommendations, right? Because we're running fine in Colab on CUDA 11.2. There is a lot of documentation from the CUDA folks who say that they strive to make all of their releases backwards compatible. And so far, I am seeing that to be true. So this was not as big a concern as I originally thought it was going to be. And then the big takeaway here is just the usage. You want to make sure you're pulling in the correct NuGet package, the SciSharp TensorFlow Redist Linux GPU, in our case, since we're on Linux. An Ubuntu environment. If you don't pull in the GPU, it will fall back to CPU if you have, just the base one in there. So that's just something to make sure. The other big one is that if you have both packages in there, the non-GPU and the GPU, it will fall back to the CPU for training. So for the SciSharp TensorFlow docs, this one was pretty critical, right? They tell you here that basically you need to make sure you download the Linux pre-built libTensorFlow SO and libTensorFlow Framework SO. These are not going to come as part of the NuGet package, so you need to make sure those are installed, as well as a couple of lower level libraries. They make the same statement here about the CUDA version. Again, we can ignore that. That should be the lowest version possible. And then over on the TensorFlow site, which is referenced from the SciSharp docs on how to install TensorFlow for C, this is a great page because it actually gives you all of the wget URLs that you need to download for what you're looking for. It tells you where to extract these and then also how to set up the linkers, right? So in our case, we actually installed using their command here. So we installed into user/local. And then very important here, you've got to run the linker command. So you have to run this ldconfig command and then set the appropriate export paths. And you're going to see all this in the notebook here once we get to it, but this is very critical. So the main thing I wanted to take away from these three sites is they kind of reference each other, but not directly. So it was a little confusing on how to get all the way to where we can actually train in Colab. But again, all these links are referenced at the end. And then finally, the project setup, and we're going to take a look at this when we move over to VS Code. The big thing here is that we just want to make sure we're pulling in the correct package. I do have all of these packages in my CS Proj at the moment because I do need to do some training sometimes on a CPU. So I will leave this, I'll uncomment this TensorFlow Redist so I can do CPU training. But the big one here is the exclude assets. So we need to basically set this to say that when this thing compiles, I don't want it to include the TensorFlow that's inside that NuGet package. And there's some reasons for this, and basically is if I allow that version of TensorFlow to come in, I can't control the TensorFlow that's in Colab, and I get conflicts, and you basically will not be able to train. And again, we'll look at this when we get to the notebook. We have to be very specific about the TensorFlow version that we're installing. And by excluding the assets here, we can control that completely and not have any sort of unnecessary things popping up that can cause issues. All right, so let's look at a demo. So first things first, let's look at some code. So the code we're using is almost a direct copy of the how to do image classification on ML.NET from the Microsoft examples. When I say it's almost a carbon copy, really the only thing that I've changed here is how I actually bring my image data in. In the example online, they actually take the folder path, they loop through it, and they build all of their input data off of the folder, right? And then they have the images classified into folders. They pull that folder name out. I'm not doing any of that. Personally, that's just me. I don't like that process. I prefer to load my data sets in from a CSV. So down here, I have this load images from CSV method, and basically all it does is it uses a NuGet package called CSV helper, and basically it'll just loop through every row in the CSV, and it will build an image data class out for me with the image path and the label, and that'll give me my enumerable to pass off to the ML context. And where that's coming from is over here, and please forgive my horrible pandas work here. I had to do this really quick. This is not ideal, but basically what I do is I'm looping over the images in the data set, and I'm basically just building the CSV on the fly. And the reason I'm doing this is several reasons. I like having the CSV for my data rather than just going off of the directory, as I said before. But also the way this code's written, it expects this training file to be inside the images folder that the training is going to happen on. So this was just super easy for me to just loop through those, build the appropriate file path, and then pass that into my trainer. Again, we mentioned before referencing the correct packet, the NuGet package for the TensorFlow. You can see that here. And then the only other thing that is sort of different from the example is this. I brought in the command line NuGet package, and basically when I run this, I basically want to be able to run it as a true console app. So I'm basically passing in some flags on what folder that the images live in, as well as what the training file should be. And then those things basically just get passed in to the trainer here. Ooh, thank you. And then, so then basically, if we look at my make file over here, I can then call it something like that, where I can just pass in the flags. Find this to be a little bit easier using that command line parser. All right, so that's really the nuts and bolts of the trainer code. Again, training image classification on ML.NET. It's a wonderful tutorial on the Microsoft site at C. This is the one where they try to classify a cracked concrete tile versus a non-cracked concrete tile. All right, so let's go over and look at Colab now. Actually, before we do that, let's look at Drive, because Drive is basically holding all of our information, right? So inside my Google Drive, I have this folder called Practical MLNet User Group. And inside this, I have an images zip. This is basically all of my training data that's been zipped up and put into Drive. I have my Colab training notebook. So this is everything you're going to see in just a second to set up the environment and actually do the training. Colab output is basically the output when I do a .NET publish on my training. So I'm basically, this is my app, and this is a .so file that got included with it. And then models is basically a folder that will hold all of our trained models at the end. So basically the way this works is to get this set up, I zip up all my training data, I move it up here, I move up my training notebook, and then I do a .NET publish on my project and bring that folder up into Drive. So now I have everything in Google Drive that I need to actually do my training on. So now we can move over to the notebook and take a look at that. And I have not pre-run any of this, so we're going to do this in real time. So cross your fingers to make sure everything works. So the first thing we're going to do is we're going to factory reset this runtime. And that's just because this thing's probably been sitting idle for about 45 minutes or so. So we're going to reconnect. You can see it's allocating, it's connecting. And right off the bat, we have this folder view over here. So you can see that it gave me some sample data. I think you're always going to get this. It gives you some data you can train on if you want to. You can see down here below how much space we have. So I currently have 124 gigs available. And then one other thing you want to note here is in the runtimes, we can go up and do change runtime type. And this is kind of critical. You want to make sure you're on GPUs. The first time you come in, this will be set to none, which means you're going to do CPU training. So want to make sure that's on GPU. You do have TPUs if that's something you want to try out. I don't think that's possible in ML.NET at the moment, but you do have access to TPUs as well. I don't know why they give you this option because I never stick with standard. I always go high RAM. I feel like that should just be a default, but you know, that's what they give you. And if you're on Pro Plus, like I said before, you could check this background execution checkbox. I am not, so I don't get access to that. All right, so the first thing we're going to do out of the gate is we want to verify that we have CUDA. And I'm doing a few things here. I want to check my architecture. I want to get some detail on the CPU, the memory available, and then I want to see what kind of CUDA version that we have. Honestly, you know, these three you don't really need. I just like to know what I'm getting myself into. So let's just run this real quick. So you can see we get a ton of information back. You know, we're on a 64-bit architecture. We're on Intel. We have a Xeon. Xeon, is that, I don't know how to say that. But as we scroll all the way down here, we're going to see our CUDA information. And this is very critical. Like, you definitely want to run this check before you do anything, because there are times where this environment will provision for us, and something will just get wacky and the CUDA drivers will not be installed. And the last thing you want to do, especially if you have a huge data set, is get all the way down to where you hit the train command and it says that there's no CUDA drivers installed. You want to avoid that at all costs. So this is just a nice little sanity check. All right, so next we're going to do our TensorFlow setup. So the first thing we got to do is uninstall whatever TensorFlow is here, because we need a very specific version. For me, I need TensorFlow 2.3.1. That is what the Linux or the TensorFlow Redis Linux GPU is going to be looking for. So basically, we just uninstall what's available. We install 2.3.1, and then we're also going to install TensorFlow GPU 2.3.1. And again, this is some of the niceties about Colabs over some of the other environments. I'm pretty sure I tried this in Kaggle and I was not able to uninstall TensorFlow. So this is just a nicety here that Google gives you a little bit more flexibility over what you can do to these environments. So again, we're going to do all this in real time. So these don't take super long, but please bear with me as this thing runs. So, you know, you can sort of see this thing working its magic. It has uninstalled. What do we have? We had TensorFlow 2.7.0. That clearly is not going to work with what we're bringing in. Just going to let this thing run a little bit. In a minute, we're going to get prompted with some big red text, and it's going to say, you've got to restart. Oh, there it went. Right here. So it's saying, hey, we just installed TensorFlow 2.3.1. You need to restart in order to use this. This is not true, and I'm going to prove it to you here in a second. You definitely do not want to restart the runtime, because if we restart the runtime, we're going to lose everything we've done. So it's not feasible to do that. We're nearly there. All right, there we go. Okay, so now we have uninstalled TensorFlow 2.7. We've installed TensorFlow and TensorFlow GPU 2.3.1. So next is we just want to make sure that actually happens. So these are just some sanity checks again. This here is basically just letting the environment know that I want to be on a TensorFlow 2.x. You don't need to do this. This is already set, but I'm a little cagey when it comes to these things. So I just want to make sure I'm being very explicit about what I want. And then we just do a pip show TensorFlow, and then we actually bring that in and show the version as well, just to triple check. So you can see here that we are on 2.3.1. We're on 2.3.1 here. We do have a 1 GPU available to us. So next, going back to the SciSharp TensorFlow docs, we are going to install these two libraries. What I did find was the libc6-dev is already there, but the libgdi plus is not there. So we'll just go ahead and get that installed. And again, if you left this install in, it wouldn't matter. It would just say it's already there, gonna skip it. Okay, those are installed. All right, and then going back to the TensorFlow documentation, we need to install the TensorFlow.so files. So then we're just gonna do a wget on that. Get those installed correctly according to the documentation from TensorFlow. All right, boom. Okay, so now we're done with all of our TensorFlow work, and we can get down to installing .NET. So you can see here, this is pretty straightforward. We're just going to download the packages from Microsoft. We're going to run git update, install, and then we're going to install .NET SDK 6.0 and ML.NET. Now again, power of Colab here. Run this command in Kaggle or Gradient notebooks. It will run. Kaggle will just do nothing. It'll just say that it ran, but you could turn around and do an ML.NET version, and it would say it's not there. Gradient notebooks would just say that apt-get is unavailable or not allowed. I can't remember the exact error. So we're just going to let this run a little bit, but as you can see, what's happening over here is the packages we've been downloading are showing up in our session. We are losing some of our space, so things are happening. This sidebar over here doesn't update immediately, so you can't actually close it and reopen it to see things that have been added in the meantime. It's on a timer, basically, and it will eventually show everything. But if you're impatient like myself, I do a lot of this. All right, cool. So now .NET and ML.NET have been installed. Let's stage our data. So the first thing we need to do is actually connect this notebook to our Google Drive. So you'll get this little message, do you want to do this? We're going to say absolutely. This is actually a new flow here, this OAuth flow. This wasn't here before. It used to make you log into Google and then get a access token. This is much nicer now. So basically just select the account you want to use, authorize it. It's a little silly in my view that I have to authorize the notebook that's running from my own drive, but I'm sure there's a good reason. All right, so the next thing we're going to do is, now that we're connected, you can see here, I'm going to unzip that images folder that is living at content drive, my drive, practical ML user group. This is going to happen pretty quick because this training data is not huge. And then the next thing I want to do is I just want to make sure all that data came over. So I'm just going to ls and get a count on what's in there. I do expect 200 images in the CD folder and 200 images in the UD folder. And we do, in fact, have those. All right, so next we need to bring in our training data. And this is one of the weird things about doing all this in Google Drive. If you're familiar, if you used it a lot, if you upload a CSV file into your Drive folder, the first thing it does is it immediately converts that over to a G-Sheets extension. And G-Sheets extensions do not work with pandas, do not work with anything other than really Google. So what we basically have to do is leave our training data here locally on my machine so I can bring it in as a true CSV. So it's kind of annoying. But luckily, we have this nice little choose file thing, and I can grab my training data. So as mentioned before, my code does expect the CSV file to be in with the images. So once it gets uploaded, basically just move that over into the images folder. And if we close and open, we should see it over here. Yep, there it is. Cool. All right, so now we can stage our code. So very similar to bringing the images over, we are basically just going to create a Colab output folder. We're going to copy our code in. So again, right here, content, drive, my drive, practical ML, net user group, Colab output. And then we do have to change the permissions on that once we copy it over, otherwise we will not be able to run it. And we just do a 777 because we trust this code. And then we just do an ls on that folder to make sure all the code came over. I have seen instances, the reason I'm doing that ls at the end is I have seen instances where it will say it copied everything over, but it actually leaves a couple files behind. So this is just a nice little sanity check so that we do, just to make sure that we got everything. And again, we can close and open this. We should see our Colab output with our training console app right there. All right, so now we are ready to roll. We have configured our environment. We've got TensorFlow set up. We've got ML.NET and .NET Core installed. We've staged our images. We've staged our training code, and we're ready to train. So this is going to move pretty fast. So I'll do my best to call out some highlights. But basically, again, you saw this earlier in the code. We basically just have to pass a train command, the folder that we're looking for. So this is images, and what file we're going to use. And again, it's expecting it to be in the same folder. So there it is. Let's kick it off. All right, so right out of the gate, you can see that we have connected to our GPU card. So we have a Tesla P100 with 16 gigs of RAM on it. And in a minute here, it's going to start chunking through these images pretty fast. Stay down here so I can stick with the, there we go. All right, so there we go. It's doing the bottleneck phases. There's only 400 images, so it moves through this extraordinarily fast. There's our training. And boom, we're done. So now the model's been created, all the training's done, and we're moving into the prediction phase, right? So there we go. So the way this code was set up, again, it's same way in the ML.NET examples. It trains the model, saves the model, and then it does predictions on it at the end. All right, so here we go. So now we have some predictions made. These look okay. It missed a couple. But again, you know, it's 400 images. I can't expect it to be crazy accurate. But this looks pretty good. And you can see over here that it spit out a whole bunch of files. And this is because I have, if we go back and look at the code, in my trainer, I have that I want to reuse the bottleneck cached values. So basically, and I'm saying, hey, just spit it out in the folder that you're working in, save those off. And if you haven't used these before, do a quick, we can basically skip all of this bottleneck training. So you can see that this thing ran in about 41 seconds. You can see the output down here. If we were to rerun this now, come on, gotta go up here. It's going to reuse these cached values, and it's going to run way faster. You can see it skipped all that bottleneck and went straight into training. So this is really nice if your image, your training data is not changing, but you need to make changes to your code. So there we ran that time in 18 seconds. So that's awesome. All right, so now we should be able to go over here now, and in our Colab output, there's our model, right? So we've got our trained model. It's sitting in Colab session. This is great. So now what we want to do is we want to copy that out of Colab and back into our Google Drive. So basically, we're just going to do a copy command on this model, and I want to put it into the models folder we saw earlier. So let's run that. Boom, done. And then Drive's a little tricky in that it is not a real-time view of your data. So if we were to go over here, it's probably going to be here because it was here before. I just did an overwrite. But it can be several minutes before this would show up in the Drive UI. And if you just spent 5, 6, 7 hours training in here, you move your model over and you don't see it for 5 minutes, you are going to be sweating like crazy. Luckily, we can just run an ls command on that folder in particular to see if it's really there. And this ls command will give you real-time results, right? So if you see it here, but you don't see it over here in Drive, don't stress. It will eventually show up in Drive. But as long as it's showing here in the ls command, you're safe. So that was a nuts and bolts sort of run through training in Colab. So let's jump back over to the slide deck. All right, so closing thoughts. Pros and cons of using Colab. You know, the pros here, it's an Ubuntu environment, and we can install things on it. We can install .NET. This is awesome, and it really sort of separates it from some of the other more popular options out there. It's free and/or cheap. Free tier is great. I would totally, if you're looking to play around with this, use the free tier. Use it for a while. Again, the main thing that sort of forced me into going pro was I had a training set of about 170,000 images that was taking up, oh gosh, I can't remember the space. It was something like 80 or 90 gigabytes. So I just ran out of space at the free tier. So right now I'm on Pro, paying $10 a month. I'm really happy with it. It's not that bad. The monthly fees are capped, and this one I really like, because when we talked about using something like Azure or AWS or GCP for training, you know, costs are kind of hidden at times, right? There's just a lot of little things that sort of add up in those environments in any cloud provider, where you don't really know what you're paying for until you've sort of trained a model, and then you realize, I just spent, you know, our entire monthly budget on this one training. In Colab, I'm paying $10 a month, and that's it. So, you know, this is really nice that I never have to worry about any surprise bills. Lots of storage and RAM. You know, again, this is dependent on which tier you're at, but I do think they give you a lot for what they're giving you. Again, we talked about this. Setup is fairly straightforward. You are going to have, I have a link to my GitHub repo for this notebook. So it is pretty straightforward after you get it all figured out. It uses Drive, which makes things pretty easy. It's not the greatest, having to sort of upload and download files from there, but it's not horrible. It's not a deal breaker for me. And you can quickly get up and running. One of the nice things about this is if you just want to do sort of bare bones, some auto ML to see, based on your training set, what algorithm is best to use, this is great, right? Because I can basically just get my data up there, install .NET. I don't even have to worry about the GPUs. I can let it run on CPU. That's fine. And I can run AutoML and do some of these sort of just initial exploratory type runs very quickly here. And it keeps all of that off of my machine, which is nice. Because again, I'm on a MacBook. The minute I launch AutoML, it sounds like I'm about to take off in an airplane. So the cons, it can be difficult to set up the first time. Again, you're going to have access to this notebook, so have at it. Please go get it. You got to use Pro Plus for background processing. And again, the more you use this, I'm getting to the point where I would love to have background processing, because I can basically kick that off, shut the Chrome tab down, and it's still going to be running. That's super nice. I don't know. I may be going that route soon. It's definitely better suited for individuals or startups. Again, if you're a big company, you have access to things like AWS or Azure, you should probably go that route. It's not a dedicated to you environment, right? Libraries could change without notice. So what I mean by that is, you know, we saw this notebook fire up. We had CUDA 11.2. We had TensorFlow 2.7. I could very well, 30 minutes from now, fire up that same notebook and have CUDA 15 and TensorFlow 2.9. You know, I'm making up numbers there, but you know, there's no way for me to say, hey, Google, I want this environment this way every time. And then single GPU sessions, right? Even when you go to Pro and you go Pro Plus, you get a single GPU. So if you're looking for more, you know, being able to do multiple GPU training, this is not the place for it. So that's just something to keep in mind. All right, so we made it to the end. I wanted to take a second here. We kind of blew through 43 minutes. That's not too bad. I want to take a second to see if there's any questions I can answer. No? Okay, I'll take it.
Hey, Brandon, this really great presentation. It's Luis here. Did you happen to try .NET Interactive, setting up .NET Interactive on these Colab environments?
Yeah, I did not, but I it's so funny because I honestly thought about that this morning. That yeah, no reason you shouldn't be able to do that, right? I mean, really, it would be as simple as just getting ML.NET and .NET Core installed, and then after that, that's a great question though. I don't know, because I'd have to install that package as well. That'd be worth trying out. You've given me an idea for a blog post.
Cool.
But yeah, I do love the .NET Interactive notebooks. That's amazing stuff.
Yep.
But yeah, you're right. This would be a great use case for that as well.
Awesome. Thanks.
All right, cool. Well, then let's just jump back over here real quick. As I said, I do have all of the links for everything that I sort of did research on. I do have my GitHub repo in here. And I do have this presentation in that repo. It's over here. I'm at Atkinson BG. You can find me in there. I will update the ML.NET user group event with this information. And then once we're done, I'm gonna get this posted to YouTube, so anybody who wasn't able to make it can watch this. And then just to wrap it up, I'm gonna grab a screenshot of the folks who are here, and I will do a random draw and reach out to you if you got the book. So if there's nothing else, thanks everybody for joining us, and again, I'll update the event on the meetup with all the appropriate links. So thanks everybody for joining.
Cool. Thanks.
Thanks, Brandon.
Thank you.
Thank you.